Hello everyone, I'm Sam from the Shenzhen Lai Shili Maintenance Service Team. Welcome to today's sharing. Today we continue with episode 9 of series 2. The first 8 episodes systematically covered the stacker's parts, from mechanical to electrical, from the stacker itself to the surrounding stations. Today is a little different. Rather than one part, we'll tie that knowledge together. Around what? The 5 early signs of declining stacker accuracy. Note that accuracy problems don't appear suddenly, they worsen bit by bit. Rails slowly wear, chains slowly elongate, sensors slowly drift. These changes give off signals early on. The key is whether you can read them. So today we cover these 5 signs, and how to intervene before a fault occurs. 4 learning goals today. First, master the 5 early warning signals, what each is and how to read it. Second, learn the measurement method and criterion for each. Third, learn how to build a trend monitoring system for accuracy data because a single reading isn't enough, you must watch the trend. Fourth, master preventive measures, intervening before accuracy degrades severely. Now the first signal, travel positioning drift, growing over time. What's the symptom? When the stacker stops at a target location, the offset between fork center and location center slowly grows, from 2 mm to 3 mm to 5 mm. Operators report it parks less accurately than before. The root causes can be several: travel wheel wear shrinking the diameter, the addressing sensor drifting, rail wear, or brake wear. The measurement is simple, weekly. Pick 5 to 10 locations and log the offset. Criteria: under 2 mm is normal, 2 to 4 mm watch, 4 to 5 mm warn and schedule a check, over 5 mm stop and investigate at once. The most important point: that trend matters more than the absolute value. 3 consecutive months of growth means intervene even if still in spec. Now the second signal, lift positioning inaccuracy. When the carrier reaches the target level, there's a vertical offset between fork and location, and you hear scraping on putaway. It's worse at high levels than low. Why? Because once the chain or rope stretches, the cumulative error grows with height. The main root cause is hoist chain or wire rope stretch, then possibly encoder count error or increased roller clearance. A very practical tip: if it's accurate low but off high, that's chain stretch. If it's evenly off at all heights, that's an encoder or addressing problem. Prevention: measure chain elongation quarterly. Clean the code tape monthly. Calibrate the encoder yearly. Next, the third signal, fork extension skew or loss of sync. As the fork extends, the 2 arms move at uneven speed or height, and the pallet sits askew. This signal also appears early. Chain tension changes occur before accuracy goes out of spec. The main root cause is unequal tension between the 2 chains, then possibly roller wear, loose mounting bolts, or slot wear. We covered the measurement before: sim, fully extend, and mark the tips, half retract, and measure the offset. A sync deviation over 2 mm calls for adjustment. Measuring sync deviation monthly is the most effective way to catch this early. The fourth signal, repeatability degradation. When the same stacker goes to the same location repeatedly, it stops in a different place each time. Operators feel the stacker is moody, sometimes accurate, sometimes not. Why is this signal so important? Because it removes systematic offset and reflects the equipment stability itself. The measurement is simple: pick one location, run 10 times, log each offset, and look at the maximum spread. If the 10-run spread exceeds 3 mm, a component has a problem. Root causes can be brake wear, an unstable addressing signal, an uneven rail joint, or drifting drive parameters. A repeatability test every 6 months is a good preventive measure. The fifth signal, abnormal noise and vibration. The running sound and vibration have changed: clicking in travel, friction on hoisting, scraping on extension. Note that abnormal noise is often the earliest sign of a mechanical fault, appearing weeks before accuracy changes. A veteran saying that sound isn't right is the earliest alarm. For sound localization, identify the source and type. A hum is a bearing or motor. A clunk is a rail joint or sprocket. A squeak means it's dry or a chain. A rattle is a guide, roller, or bearing. Prevention: listen at startup every day. Set a normal sound baseline for each unit, and log and track any abnormality at once. This page focuses on inspection tools and measurement standards. Each signal has its own tools. Travel positioning uses a laser meter and steel rule. Hoist positioning uses a tape and level. Fork skew uses a dial gauge and level. Repeatability uses a laser meter. Noise and vibration use a stethoscope and vibration meter. The method must be standardized. Always approach from the same direction to remove backlash error, and measure and analyze by low/tashurud. The key point: only a consistent method makes data comparable. Setting a normal sound baseline for each unit also matters. This quick reference table summarizes the 5 signals: inspection frequency, warning thresholds, common root causes, and recommended actions. To run through it: travel drift measured monthly, hoist positioning quarterly, fork skew monthly, repeatability every 6 months, noise and vibration listen to daily. Each signal has a clear warning threshold. Print this table and post it beside the equipment. The key is only data gives a trend, and only a trend lets you warn ahead. Start building an accuracy record for each unit today. Now let's go deeper into the heart of the prevention system: the 3-color warning. Green is normal, keep logging data and watching the trend. Yellow is watch, measure more often. Switch from monthly to weekly, and schedule a planned check and adjustment. Red is alarm, investigate immediately. Don't wait. How is the trend chart built? Time on the x-axis, deviation on the y-axis, each measurement connected into a trend line. The rule: 2 consecutive months of rising deviation is a clear yellow signal. Review cycle: a quick weekly walkaround, monthly measurement and logging, quarterly analysis, annual full assessment. Building an accuracy archive is the cornerstone of prevention. Create an independent record for each unit with 4 sections: equipment data, the accuracy data table, trend analysis records, and repair history. Use Excel or a dedicated CMMS to manage it. The sample sheet shows how to log each result with a color-coded level. Keeping up the records is the most important thing. Don't wait for a fault to start looking at the data. Start building an accuracy archive for each unit today. Here's a real trend analysis case. A warehouse had a monthly accuracy check routine. In month 4, they found that stacker IS3's travel offset, though still within 3 mm, had risen for 3 straight months. They decided not to wait, and investigated early, finding the travel wheel worn by 2 mm. After replacing the wheel and recalibrating, the offset returned to 1.2 mm. Think about it: without trend analysis, waiting until the offset exceeded 5 mm would have meant hundreds of bad picks puts by then. Acting 3 months early avoided a batch failure. That's the value of prevention. Data-driven maintenance decisions. Let's recap today's key points, 6 of them. 1. Remember the 5 signals: travel, hoist, fork, repeatability, sound. 2. The trend matters more than the absolute value. 2 or 3 months of rising deviation calls for action. 3. Run a 3-color warning system. 4. Listen at startup every day. A veteran's ear is the best sensor. 5. The core of prevention is data and trend. Keep an accuracy archive per unit. 6. Early intervention costs far less than after-the-fact repair. This page is the monthly precision maintenance schedule, with the cycle from daily to annual at a glance. Daily: before startup, listen for abnormal noise. Weekly: measure travel offset. Monthly: measure sync deviation. Quarterly: a full check. Semi-annually: a repeatability test. Annually: a full assessment. The execution points are summed up as 7 fixes: fix the person, the tools, the method, the criteria, the cycle, the records, and the feedback. Get these 7 right, and accuracy management truly takes hold. That's it for today. We covered the 5 early signs of declining stacker accuracy: travel positioning drift, hoist positioning inaccuracy, fork extension skew, repeatability degradation, an abnormal noise and vibration, and how to build a prevention system. The one line to take away: the trend matters more than the absolute value. Next episode covers the daily inspection checklist for the stacker's safety devices. Safety is the premise of all maintenance work. Thanks everyone. See you next time. At the end of the course, let me introduce our core business. The Le Chile Vietnam team specializes in providing logistics, automation, equipment maintenance services for local Vietnamese enterprises. We have a dedicated local service team, which is much more efficient than remote coordination. If you need any help, feel free to contact us anytime.